All right. Participation, active participation is going to be extra credit. We will have discussions. Right or wrong, don't censor yourselves. All right, just join in the discussion. I'm going to give you guys participation points for everything that you say. It's not required. Active participation is not required, but encouraged. And I'm going to give you plenty of participation points. All right, so I'm going to start off with the big picture. So let's talk about time travel. All right, so speaking of time travel, is it possible? All right, everything is going to hinge on the observation. It's going to be related to time travel. And it's also going to be related to parallel universes. So this course is going to be kind of weird. All right, speaking of time travel, how many of you guys believe that the time travel is possible? What do you think? Anybody?
I think that it could be possible. There are many factors that go into it.
All right, Madeline, what do you think? I mean, just tell me how that's possible.
I feel like with today's technology and everything, we would be able to create something like that. I don't know how perfect it would work.
All right, so Madeline, you're thinking that it's a technology thing. All right, so here's what I'm going to do. I'm going to give you guys, Madeline, give yourself 5 points for that one. All right, I'll give you a scenario and tell me what you guys think. If time travel were possible, we would be able to travel 100 years into the future, spend 18 hours there, and come back with the next fraction of a second. All right, so if time travel were possible, I'm making 3 statements. We could be able to travel 100 years into the future, spend 18 hours there, and be back in the next fraction of a second. All right, so out of the 3 statements that I made, the first one is with the possibility of time travel, I'm leaping 100 years into the future. And then second statement is I'm spending 18 hours there. And the third statement is I'm coming back within the next fraction of a second. All right, out of those 3 statements, which one do you think is probably not correct? All right, say it again.
You're coming back in 18 hours.
No, I'm spending 18 hours there. I'm coming back in the next fraction of a second. Jesus.
After that, the coming back in the fraction of a second.
All right, so Jesus, you got a problem with that, right? If I'm spending 18 hours somewhere else, you're thinking that it doesn't make sense for me to be able to come back in the next fraction of a second, right? All right, Jesus, I'm going to give you 5 points for that conclusion. You actually believe in time travel. All right, who else? Out of those 3 statements, so I'm traveling 100 years into the future, spending 18 hours there, and come back in the next fraction of a second. Which one strikes you as bizarre and impossible?
Why would you just travel 100 years in the future where you can go further?
Oh, because, well, there's no reason. It's just an example.
Oh, okay.
All right, Kylie, what do you think? What doesn't make sense to you?
It doesn't make sense to me. About how little, like if you go there for 18 minutes, how little time it makes a difference to your time. A little bit. It's like if you spend 18 minutes there, 18 hours there. I mean, I only need a second over here, so it just means such little time.
All right, so you have the same problem as Jesus did, right? All right, so I got news for you. You also believe in time travel in a strange sort of way.
Forward.
All right, say it again.
I believe you can travel time forward. At least right now, what we see, like in the physical world, we're moving forward in time. So 100 years in the future isn't impossible. But coming back to me is where I have trouble.
All right, so Jesus, you get a problem with coming back, right?
Yeah.
You're fine with going forward in time. All right, once again, you're still a believer. I'll give you 5 points. There's no question. All right, who here does not believe that time travel is possible? Guys, we do time travel, right? 1 second at a time. That's not what I'm talking about. I'm talking about literally leaping 100 years into the future, spending 18 hours there, and possibly coming back in the next fraction of a second. Can we do time travel? We're already doing time travel 1 second at a time. So the question is this. Notice that you guys assume that 100 years from now is already happening, right? So do you think that the future is happening as we speak? About the past?
Yes.
Do you think that the past is happening, Jesus?
Because
yeah, go ahead.
I heard it just a while back. I mean, you can completely tell me if I'm wrong, but I remember hearing that since light is still traveling through the atmosphere, not atmosphere, but through the universe, the light of like our old ancient times, depending on how far, because time is relative through like space, right? So it's like isn't like if an alien were to be, I don't know, 2 billion light years away from us, or 200,000 light years away from us, wouldn't they see our past instead of our present right now? Wouldn't they see the light that was traveling from our universe a while back ago?
All right, Jesus, I'm going to give you 5 points for that statement. So at the same time, I'm going to ignore it just for now. That's something that we will go back to eventually. I think you're making a solid point, right? What you're saying is the stars that you guys are looking at, a star which is about 1 million light years away, you're looking at the star the way it was about 1 million years ago. It doesn't mean that the star is there today, though, right? All right, so you're just looking at the star because the light travels at the light speed, and light speed has a finite value. So the star that you're seeing is the star the way it was about 1 million years ago if it's located 1 million light years away. For example, the sun that we're looking at right now, you're looking at the sun the way it was 8 minutes ago. That's what it means. All right, so let's get back to the question. Can you travel 100 years into the future? For you to be able to travel 100 years into the future itself has to exist right now. So do you think that the future exists and happening as we speak? Do you think that the past is happening and still exists as we speak? You guys know that you can actually go to if you wanted to go to Paris, if you had the time and money to do so, you can, right? Because there's a place called Paris that exists where people kind of speak gibberish. But for you to be able to travel 100 years from now, the 100 years from now, it has to be happening. Is it happening right now? It's not, right? Do you think that the past is happening right now? The answer to that question is not. Do you think Hitler is still conquering Poland? The answer to that question is no. The past is just a memory. It's a history. The future is a possibility. So can you actually travel to a time that doesn't exist? So what do you guys think? Do you think that time travel is possible if that's the case? The answer to that question is going to be no, absolutely not. The time travel cannot be possible. You cannot travel forwards in time into a time that doesn't exist. You cannot travel backwards in time into a time that doesn't exist. We'll say the skeptics. Einstein will say, yes. Now, for you to be able to do time travel, the future needs to exist. The past needs to exist. The future needs to exist and needs to be as real as the present. The past needs to exist and needs to be as real as the present. As far as Einstein is concerned, as far as Einstein's theory of gravity is concerned, that's exactly what it is, guys. The time is a continuum. The time being a continuum means that the future, the past, the present all exist at the same time. And all of them are equally valid, and all of them are equally real. So Einstein's theory of gravity is what makes time travel possible. Plausible, more like it. So what's gravity as far as Einstein is concerned? Is a warp of this space-time continuum. Space-time continuum, if you warp it, and the only way you can warp it is using mass, is this warpage, this curvature is what you experience as gravity. Now, for gravity to exist, the future, the past, the present, all need to exist at the same time. So there are 3 conditions that need to be satisfied for time travel to be possible. The first condition is the time has to be a continuum, which means that the future, the past, the present, all need to exist at the same time. All right, so with that, we got some problems.
This is a Mobius strip. One surface, one side. Here, try it. Make a line on it.
This is wonderful. This is a Mobius strip?
Yeah.
I'm going to show them that at school.
Mobius strip 2-dimensionally, it looks like this. All right, so what does this look like? It looks like a sideways 8, right? So what do we call this? We call this the infinite. Go ahead.
Oh, sorry. It just looks like an infinity where it has no end nor beginning.
Okay, very good. All right, each and every single point on the Mobius strip not only will represent a time dimension, space dimension, x, y, z, it's also going to represent the time dimension. All right, so this could be a point in the present. This may be a point in the future, point of time in the future, and here's a moment in the past that you're looking at. So notice that each and every single point not only represents the x, y, z dimensions, but every single point is also going to represent the time dimension. So each and every single point represents a moment in time. So notice that this moment in time, the present exists, the future is going to exist, the past is going to exist. Now, for us to be able to do time travel, space-time continuum needs to be curved. Why does it need to be curved? If it is curved, time travel is going to become possible according to. All right, so this guy, his name is Kip Thorne, is going to make time travel possible for us. He's a theoretical physicist, recently. And here's a picture of him from his hippie days from 1970.
Sagan, the noted astronomer, was writing a science fiction script called Contact, meeting extraterrestrial life forms. But he had a problem. The distance between stars is so great that it would take centuries to visit other planetary systems. And because of the time dilation problem, he decided to ask a physicist, is it possible to go these enormous distances in a twinkling of an eye?
Sagan called Professor Kip Thorne, a noted expert on Einstein's theory. Thorne struggled with the problem for some time. Then, in the back of a Ford Bronco, as he was driven along Interstate 5, he made one of the most inspiring connections of modern physics by linking Carl Sagan's cosmic conundrum with the exciting new concept of wormholes.
A wormhole is a hole in space that may give us a shortcut between 2 points. For example, if I had a super microscope and I could peer right into the fabric of space and time, I would find that it's not smooth at all. It's foamy, it's frothing, with tiny little holes and bubbles. If science can somehow tease apart one of these holes in space, we could actually connect 2 distant regions of space and time. Now, where have you seen that before? In Alice in Wonderland's Through the Looking Glass. The wormhole was Alice's looking glass that connected the countryside of Oxford with Wonderland, such that when Alice stuck her hand through the looking glass, her hand went through the wormhole and came out on the other side of forever.
Thorne was triumphant. Wormholes were an exhilarating means of connecting 2 points in space. It was only later that the full implications hit him. If wormholes could cheat space, they could also cheat time.
All right, so who's the name of the guy who came up with the idea of time travel through wormholes?
Kip Thorne.
Very good. Just remember that name because that name is going to keep coming up. So Kip Thorne is the guy who came up with the idea of time travel through wormholes. Okay, so what are these wormholes? Notice that the wormholes are shortcuts for the space-time continuum. If you have a wormhole which is connected to the future, it's going to take you to the future. If you have a wormhole connected to the past, it's going to take you to the past. All right, so here's your wormhole connected to the future. So you can go to the future. Here's a wormhole connected to the past. It's going to take you to the past. All right, the journey itself takes absolutely no time at all. Guys, you're in the present. You can leap 100 years into the future, spend 18 hours there, and then come back in the next fraction of a second. Or you can leap 100 years into the past, and then spend weeks there and come back in the next fraction of a second. That's what it means. You can come back by the time you leave, actually. Or you can come back before you leave. It makes no difference. All right, so this sort of stuff becomes possible only if there are shortcuts inside the space-time continuum. So there are shortcuts that we can take to do time travel. All right, so here's your shortcut to the future. Here's your shortcut to the past. So Kip Thorne is the guy who
Going forward in time at near the speed of light is relatively easy. Traveling backward in time seems all but impossible now, but it isn't ruled out by Einstein's theory.
All right, so let's have a quick discussion. Can we actually take shortcuts through the space-time continuum? All right, so for us to be able to do something like that, the first thing that needs to happen, literally, is we need to create wormholes. Okay, so what are these wormholes? Wormholes are 2 black holes connected together. All right, so if you have a black hole from the future connected to a black hole from the present, then it's going to give you a wormhole. Do we have black holes today? Of course we do. Do we have black holes? Did we have black holes yesterday? Once again, the answer to that question is yes, right? Do you think we are going to have black holes tomorrow? More than likely. So if Kip Thorne is correct, if the future, the past, the present all exist at the same time, and then if these black holes become connected, then they will turn into these wormholes. All right, we got a bunch of problems. One of the problems is when there's a connection like that, those connections only last for a fraction of a second. The second problem is you're dealing with black holes. At their centers, the black holes are going to be smaller than the smallest atoms in your body. All right, so if you were to jump into one, depending upon the connection points of these wormholes, if the opening is not large enough for you, you can get crushed. And the third problem is the radiation. Tremendous amount of radiation. So much radiation, in fact, that you will get vaporized. So there's no way you can actually do time travel through these wormholes unless you can stabilize these wormholes. So the question is, how do you stabilize these wormholes? That will make time travel possible.
If Joe Tanner in his super shuttle wanted to go back in time, he would have to locate a black hole. And not just any black hole, a special black hole connected to another light years away. The resulting tunnel in time and space is called a worm.
All right, so what are these wormholes? These wormholes are shortcuts for the space-time continuum, and they will only come into existence if black holes from different moments in time become connected somehow. They're highly unstable. I mean, obviously they exist in theory, and if they do exist in reality, they would be highly unstable, and you would have a bunch of problems. The problem is the opening at the center may not be large enough for you to go through, or the radiation